Ok, va bene, grazie, prego. The title is Layered Ceramics on Non-Precious. Sì, ma non lascio spazio. It's really I'd like to talk about why adopting new digital technologies. Why it is necessary to use alloy structures and which ones. How to select materials and combine them in prosthetic solutions. how to treat structures to optimize aesthetic coatings. In the digital age, there are many aspects in which our dental world is now involved, both the dentist and the dental technician. Today, the digital aspect is very important. I am also equipped with new technologies, such as 3D printers, model scans, intraoral scans, CBCT scans, and wet-dry CNC milling. I am equipped with the new technologies, digital software and printers. The flow, the work in the laboratory is changing. So for me too, from analogue to digital, which means combining together. This does not mean that one prevails over the other, but it is right to learn to transfer our digital experiences. So this is something that I experience every day. Digital is covering a lot in the laboratory, 70% and growing, as there are necessarily digital dependent materials, or because dentists today use impressions a lot. But I must not forget exactly what my type of work is. There are situations that favor the various options related to materials, planning, procedures. These are the 3 key points I need to keep in mind. For me, it's important to work with a team. We have to follow precise plans. Materials and different solutions. We must learn to know and manage them. Natural, metal, ceramic, feldspar, disilicate, composite, zirconia. So today, as you know, we have many more possibilities because of all the different materials that we are able to use, and we take advantage of these opportunities. Now, the objectives: to have very simple systems which are comfortable and comfortable for both the dentist and patient. Durability, guarantee, duration, and maintenance are very important. There are clinical needs for the choice of materials: versatile, repairable, manageable, reoperation. The choice of the laboratory must be convenient for the dentist also, from the point of view of work management. Durability. I will start with a case report. A case of metal ceramic, then ceramic layered on the metal. Then I check after 25 years. If everything is done correctly, we have a high quality work. 4 metal ceramic crowns, checked at 25 years. These 4 crowns come from a 1994 case in metal ceramic, ceramic fused on alloy. Of course, the choice of material is important. Material that will last over time. This case was seen in 2019 and represents the duration. Both the dentist and the patient are happy with our choices. Therefore, the choice of ceramic metal is a winning solution. So internal and invisible effects are important. Fluorescence, which have to look like natural teeth. Opalescent effects, reliable adhesion by alloy from the point of view of adhesion. Why do I use feldspate in ceramics? It is not natural. Noritake does not use natural feldspar. On the contrary, it obtains the silicon part that makes up the feldspar with a process for synthesis in the laboratory, a material that uses technology in the laboratory and not mineral extraction. What advantage does it give me? It gives me the opportunity to have a comparison between natural and synthetic ceramics before having much purer crystals. The benefits are purer crystals and cleaner ceramics. The advantages are also compactness and stability, particle distribution, a comparison of Noritake and other ceramics. There are many research projects. Here are 4 kinds of ceramics. Firmness of ceramic, a much more natural surface, closer to that of a natural glaze. Natural enamel, synthetic ceramic, natural ceramic, and factors affecting enamel and ceramic wear. We always want to produce the enamel that looks natural. Like natural teeth. Here is an important quote. Hardness is not essential in dentistry. Compactness and the quality of the lucite are key to prevent the natural antagonist. And this is a very important choice. Another important choice is coefficient of thermal expansion. Knowing that the set of a chromium cobalt based alloy is around 14.1 and 14.4, I have a ceramic that rightly has 2 points less, 12.4. But the advantage of a synthetic ceramic is linked to the fact that by producing less lucite in the firings, it continues to have a stable coefficient. But other natural ceramics, during several firings, the coefficient changes and the problem of cracks arise. An example of standard work. So where the work path is analog, you can see the analog impression. Passivization protocol. According to Dr. White, that indicates a precise protocol for which the modeling phase must be absolutely stable and precise. Considering all the deformations we have in the resin and wax, Dr. White showed us the fact of building these resins. The Sheffield test, where a single screw must hold the perfectly matching and precise structure on the copy of the analogues. All this I have to take up in the fusion technique, advanced techniques. Thanks to Mesa materials, we can work at a high standard. And we have had better techniques. Heat treatment. In addition to passivation, it is important to have programs for heat treatments that guarantee the stabilization of the alloy so that they do not turn into problems when I go to ceramize. We have to look and see how the structure is behaving. Ceramic layers and opacification. The ceramization. So the heat treatment is very important, not only the choice of material. And here we are about to finish the work. The structure must always be very stable, very passive. Materials that can help us: wax milling, excellent thermal control, and excellent milling. For example, the disc of Mesa Magnum Iconos. We can do this with a file in the digital age. A single pin, a very interesting technique, convenient from the management point of view, using a new generation alloy for excellent structural quality. I found this very interesting, this technique, the technique of a single pin. It's not what I'm talking about tonight, probably by other colleagues. This is a photo by my friend Adriano, who shared his single pin technique. It was he who helped me to use this system to enlarge what I'm able to do. New generation casting alloys. I use Magnum Splendidum. It has a very interesting CTE, a very stable alloy during firing, and load resistance. Vickers hardness 273 HV10 and load resistance 361 MPa. It has excellent load resistance, and I can use it in many different ways. It is excellent. Bonding and opacification. This is very important. It can change the appearance. It is a kind of masking. I like to use Bonder, which helps me above all to shield the oxidation I have, which could affect the final color. I apply it in two parts. First application and second application. Now the firing. The oxides favor the bonds and determine this coloring. This is very interesting, this transformation. When I go to cover the opaque, it is also the lightest that perfectly covers my structure. The bond also helps me to shield. I use two applications, so it perfectly covers the surface. Opaque before firing. I do a powder drop of opaque to make it more wrinkled. Now the stratification. They are ready to be covered with ceramic. First of all, I produce the cones and then I cover them with the stratification. And here we can see a case. We see stratification by cones, depends on the color. We have a clinical case of a posterior sector in antagonism, upper and lower, where we know that the chromatic dominance has its importance. Yes, I participated in the book Ceramic Multilayer Technique, Thermal Steps. So there are 4 stages: sandblasting, bonding, first opaque, and second opaque. It's important to have a well-defined layering project, to have a very clear idea about the kinds of materials to use. The first thing to do is the dentinal core. Here are the first steps of firing. Opaque, opaque, dentica, dentin, cutback, and translucent material. It depends on the color I use. With Noritake, I have an interesting opportunity, that of producing the eternal effects with a stains technique, through which I have the possibility of coloring internally. It is presented by Oshima. It allows me to check the color. Internal live stain techniques. It is a master technique. It is a very simple technique, but it solves difficult problems. Modulating the value on the fired mass. I can lower the value at will, or I can increase the chromaticity at will. According to the seasons of the tooth, I can reproduce high definition effects comfortably on the baked mass, young, adult, elderly, old. In every season, there is a transformation on the tooth. They have their own characteristics. External morphology through luster enamel. I have to use specific material here. To get the right effect. This is called luster. Then I go to the second firing. I complete the morphology, well done in the oven with 5 elements. New luster masses update to inform Noritake users. The color options. We also have new methods of stratification. The luster thickness must be 0.5 millimeters to be really effective. Mechanical finishing. My work protocol using diamond tips, stone tips, and finally with a paper cone. To finish. Before finalizing all the work, the weaving, the macro and micro forms to try to obtain what looks like natural enamel. It varies according to age. I will modulate the type of finish. The microforms are almost lost completely in older teeth with older patients. Also, you can see here the final polishing based on age, more intense in the young tooth and less intense in the old tooth. To achieve excellent texture, Noritake does not need glaze, all done without glazing, only through mechanical finishing. It is very compact. So I underline the importance of being compact. Another clinical case that gives the dimension of duration. It is an image from 1996. The work has to be redone as the patient is no longer happy. Let's review the protocol. Start with a provisional. Through this provisional, we give the dentist indications about the preparation and the necessary thickness. Preparation and thickness. This can help give the dentist a lot of information. And we can explain to him what information will help us. This cooperation is important, not just for the patient. We finalize before firing with 3 layers of ceramic. I insert the HD effects. Fixation. And then the second and last firing on the surface with ceramic with luster effect. And then finally, autogloss at 900 degrees in the oven. For PFM, porcelain fused metal. The work is finished under polarized light or standard light. It was completed in 1996. You can see how the light helps us to understand the quality. Here is the case checkup in 2019 after some time. Ceramic metal still represents a key to success today. It is ideal. The digital age offers many opportunities in other directions too. In this case, it starts with a smile design. I proceed with a 3D digital project before definitely proceeding with the final work. The dentist today has the opportunity to try what I have designed digitally. The final solution through a digital workflow can be tried in the patient's mouth. Cad and Cam, the ceramic work completely replicated with Cad and Cam. It is highly requested. We can have an excellent aesthetic result. Digital is especially interesting in complex cases. We start with a prototype that must be exactly the replica of what I want to create. I use dedicated alloys milled with magnum splendidum. It is interesting material. Excellent load resistance and excellent stability during veneering. Mesa has given me this wonderful material, which is very stable. Milled structures with an anatomical design that also favors ceramic support. It is important that this ceramization phase, you have followed the procedures for which it has a stable structure, even during the ceramization, and therefore also in the need to correct, always thinking of having a subsequent correction. Two Toronto bridges made with the structure cobalt chrome base alloy. The stratification, feldspathic ceramic, gingiva feldspar ceramic. It is important to have respect for the technical procedures. In this case, alloys for Cad and Cam, solar magnum. At the end of the mechanization, even if the Mesa disc is not a cast disc, but obtained with an advanced technology, the structure is full of tensions. A dedicated thermal process is recommended for structural stress relief. That's why a dedicated thermal process is recommended for structural stress relief. The technical procedures I advise is homogenization and stabilization. It's recommended with mechanical finishing, a vacuum, and maintenance. Then the mechanical finishing. And then I can proceed with sandblasting at aluminium oxide 50 micron, 2.5 atmosphere. Thermal oxidation without vacuum. Mechanical adaptation and finishing. And first bonding layer recommended. It's not compulsory. I put a layer of bonding on. It's what I advise, but it's not absolutely necessary. Then the second bonding. The first opaque layer and the second opaque layer. Then the first ceramic firing, the fixing internal effects, and the final firing and polishing. mechanical self-glazing. These all work if I've done everything correctly. The evolution of materials, ceramics. They are very aesthetic. In the treatment of edentulous patients with implants, the dentist requests minimally invasive and affordable. Patient satisfaction and manageable for the clinician. The patient wants something which he's satisfied with. Of course, the clinician must be able to manage this. Composited. I need a structure. I choose alloys of titanium. The very interesting solution. I like a titanium that gives me a perfect solution. Anatomical structure is a good opportunity. I have to have a good plan. I need a phototype to begin with. For the nose and old prosthesis with a PMMA prototype on which to study the case. Which gives us an idea what the final product will look like. Now I can do it in digital. The analog model control, a very important phase for this type of work, is the control of the model, whether it is analog or non-analog. Magnum splendidum cast alloy key. You see the superior, the processing comes from the prototype, following the anatomical and structural design. It is much more slender. Digital modeling comes from the prototype. It's a combination of analogic and digital. It's thanks to this wonderful material that I have today that I am able to do all of this. Titanium 23 from Mesa. In this case, I use grade 23 titanium, Mesa Magnum Hyperon, a new generation of titanium. We have a good millability. Despite having good mechanical resistance, which are very important characteristics, in addition to oxidation that promotes adhesion and a good resistance. This is very important for me. T-base bonding as an important bonding technique. On implants, I use the T-base as a connection solution for the implants. So it lends itself very well to the bonding technique as it connects with the framework. You can see the anatomical shape. And then the setup in muffles. The tested prototypes are placed in muffles to memorize the shape because the request is composite and must be pressed. These muffles are a kind of flask. Substrate treatment. Before pressing, I have to take care of the treatment. My choice is titanium because it has excellent spontaneous oxidation. I collaborated with the university for this test. I did some tests where titanium represents excellent adhesion for composite materials. The cleaning and sandblasting of the structure is very important. In, in, invisible opaque. I use an invisible opaque that allows me to have an excellent metal composite union. Later, I can dedicate myself to colored opaque. The photo of a polymerization. Very fine layers. Substrates. Studying the substrates, it can be seen that dentine has a much lower elastic module than enamel, therefore promoting cohesion. It has a very low elastic model. The composites have very low elastic muscles. Substrates, I slightly emulate the composite with reverse hardness layering. Put the soft compound inside and a more tenacious composite outside. I have published this technique. tender, opaque mass. It helps to promote adhesion to the structure, soft. It absorbs the mechanical load. And it's ready to be pressed. Then I move on to pressing the composite. Interior effects. I refine and apply interior effects as I do with ceramics. Pressed enamel. By pressing, I get the white coating in a single face. The pink composite is missing. To optimize the work, I dedicate myself to the pink composite. I also published a chapter in the book. You can see the finished work. See the occlusal part of the work, the steps of the screws that the dentist will then cement. So cementation by the dentist, so that these steps are shielded. Now the total digital workflow. It is more evolved nowadays. Here are digital impressions. We can have a digital model. This is the printed model. And here is the checking phase. We have to check the model. The model verification. I would like to be sure of the stability in the mouth. I can take one and merge it into magnum spellidum. The digital project. I go on with the digital project, which starts with 2D and then in 3D for the volumes in CAD. I design the anatomical structure. Again, the work is done in titanium, composite titanium. Composite finishing as shown. The dentin, finishing of the internal effects, pressing of the enamel and layering of the composite. Toronto Bridge with titanium plus a composite structure. A Toronto Bridge made with a titanium structured and aesthetically made or pressed microhybrid compounds. The last type of material, multi-layered zirconia. 3D zirconia is also a required material for which even we technicians must adapt to. It is good for the aesthetic approach. "3D liquid ceramic", a new type. It can be useful to combine it with liquid ceramic. Three-dimensional. Very thin layers. Very thin micro layering, which allows very fine layering down to the micron, down to 30 micron. Very, very slender. Full contour zirconia for an aesthetic result. Very important steps to follow to obtain an optimal aesthetic result. The digital process is very, very important in this case. The Toronto Bridge request. It may be interesting to combine zirconia requests for a Toronto bridge. In this case, the information is totally analogic. Checking the models. Also in this case, I do some checking in the mouth. To be able to check the stability. Analog aesthetic functional recordings. You can see here a first aesthetic recording, but I won't be dealing with that at the moment. The digital project shape. Then move on to a 3D design of what the idea of the work may be. PMMA milled prototypes. It is important to make prototypes first. Prototypes to check in the mouth, which the dentist can check in the mouth for shape and aesthetics and make any corrections. Final solution project structures. If the project is accepted, I can proceed to the final solution. From the volume, we have the structure, so we can create some abutments. I want to put two different materials together. I want to merge mechanical retentions for the gingival area. They are milled in wax, which we then milled in Iconos wax. The mechanical retentions for the gingival area you can see. They want to melt because they will then be made of a micro composite. So I want to create micro retentions where I'm going to apply the pink composite. Fused structures. Let's move on to the fusion with the magnum splendidum. Very precise. And then I'm ready for the next phase. Scanning structures and removing the single copings from above. And before zirconia fabrication. The milled resin thimble prototype. We have to make prototypes with a milled bar blocked with wax. It helps the dentist to be able to check better. Transformation in full contour zirconia. The dentist approves everything, and it is made in zirconia. You can check the scan. ml zirconia after sintering. The crowns are multi-layered. We are ready for ceramic microstratification in 3D. And here you can see a photo of the finished work. So it is ceramic microstratification. The bonding. The next step. Opaque gingival area. The pink layered composite. The assembled solution, which allows you to intervene easily, even after years, also to repair the structure, which is made of metal. It is easy to work on this material again, even over time. It makes it easier for the dentist and for us. This is all thanks to this new material. Here is the Toronto assembled, made from splendidum cast alloy, multi-layered with ceramic, liquid ceramic. Now, to conclude, I would like to leave a message about this new type of intervention. New digital technologies are essential today for an efficient and controlled workflow. It is necessary to use alloy structures for their versatility and possibility of use in different options. The advanced characteristics of today's aesthetic coating materials allow us to combine them for more winning treatments. It is essential today, through knowledge, to identify an ideal criterion for the choice of materials and combine them in modern prosthetic solutions. I cannot underline enough what I have already said about the importance of these new materials. It gives us a high standard and they last longer and the patient is more satisfied. It's really important to know about these materials, to have a knowledge of them. You really have to know these materials so that you can have a choice of materials. Thank you to the translators and thank you to my team. This is my team that work with me here in Italy. Analogic and digital. And I thank you to Mesa for holding this webinar. Thank you for all the help you have given in realizing this webinar so that I'm able to talk about my work. Thank you very much for your attention and thank you, Mesa. Thank you, Daniele. And thank you for following us right to the end. Okay. Thank you and goodbye.